Peering into the eyes of different animals, you'll see some extraordinarily shaped pupils. But why? It turns out that pupil shape is a powerful indicator of what role an animal plays in its ecosystem. Pupils mark the hollow opening in the iris, the eye's band of pigmented muscle. They're the portholes through which light enters the eye, where it then strikes the retina and activates light-sensitive cells, setting the process of vision in motion. Pupils are black because most of the light that enters them is absorbed. Their size changes in response to brightness, as well as certain drugs and emotional and mental states, but their basic form varies greatly among species. House cats, for one, are twilight hunters with vertically elongated pupils. In the dark, these structures expand dramatically, taking in the available light. When it's bright, they shrink into slits. In fact, cat pupils are so flexible that their maximum area is 135 times greater than their minimum area, whereas our pupils only shrink and expand 15-fold. And because of how the slit pupil takes in light, it creates sharp, vertical contours. When the cat's brain processes the visuals from each eye, the small but sharp differences between them help the cat judge the precise distance of its target. In fact, many other ambush hunters also have vertically elongated pupils, but mainly those whose eyes are located closer to the ground. This may be because these pupils are especially useful in perceiving objects at the relative short distances these animals tend to hunt. The world looks very different from behind the horizontally elongated pupils of many grazing and browsing animals, like goats. These pupils, situated on either side of the head, let horizontal bands of light in that give the goat a near 360-degree view and provide it with sharp, horizontal images. This helps goats detect any disruption to the horizon, alerting them to potential predators, while still enabling them to see ahead and detect obstacles as they make their escape. In fact, goats always keep their pupils aligned with the horizon, rotating their eyeballs in their sockets as they move their heads up and down. Meanwhile, nocturnal geckos have pupils that shrink into slits studded with pinholes in higher light conditions. Each pinhole projects a separate, sharp image onto the gecko's retina. Scientists think that comparing these different inputs might help the gecko judge distance without having to move. And while they might have fooled you, mantises and other insects and crustaceans have pseudopupils. These aren't optical structures, they're optical illusions experienced by the observer. Mantises have compound eyes composed of thousands of light-sensing units. When some are aimed at you, they appear black because they're absorbing most wavelengths of incoming light, but there's no actual opening. So why do we have round pupils? Elongated pupils help sharpen certain dimensions of an animal's vision. But scientists think that for animals like us with circular pupils, this is a lower priority. Instead of seeing some elements of a scene in extreme focus, we see a larger picture in relative detail, which enables more general skills of observation. This may be especially helpful for foragers looking for food, hunters eyeballing and chasing their prey, and social animals recognizing other faces. As we peer at different pupils, patterns emerge, and yet there are exceptions. For example, Pallas's cats and mongooses are both small ambush predators, but the Pallas's cat has round pupils, and mongooses have goat-like pupils. And we've only explored a few pupil shapes. Other animals have crescent or heart-shaped pupils, and the cuttlefish has perhaps some of the most bizarre. Their pupils are circular in the dark, but W-shaped in the light. So what's going on here? Well, wouldn't we all like to know?